Number 96. To receive AM radio, you want an RLC circuit that can be made to resonate at any frequency between 500 and 1650 kilohertz. This is accomplished with a fixed 1 microhenry inductor connected to a variable capacitor. What range of capacitance is needed? All right, so there's several ways to approach this kind of a problem. Anytime you're dealing with resonant frequency, just know that resonant frequency occurs when the reactive inductance will equal the reactive capacitance. Okay, now we know from the prior section the formulas for these two, right? The reactive inductance is 2 pi times the frequency times the inductance. And the reactive capacitance is 1 over now, 2 pi times the frequency times the capacitance. Now, since the question is basically asking me to find capacitance, I want to solve this thing for C. So I'm just going to cross multiply it on out. That means I got to bring this whole bunch of mumbo jumbo down into the denominator over there. Look at how fast that is. Now we can clean this up a little bit. Notice how I have 2 pi's in there. I have two 2 pi's, right? Two pi's. So 2 pi's is going to be squared. Okay. Then I have 2 frequencies, so that's squared. And then I have the inductance. So now what I need to do basically is I need to create now 2 equations. All right. One that will talk about the, I don't know, minimum capacitance first, maybe. Now notice the minimum capacitance will occur at the maximum frequency because they are inversely related in this formula. All right. As the denominator increases, the overall fraction here, which represents the capacitance, decreases. So this is then going to be equal to 1 over now, 2 pi squared, times the frequency. Now the highest frequency here is the 1650 kilohertz, okay? So that's going to be now 1650 times 10 to the third, because we need that in hertz, squared. Multiply then by the inductance of 1 microhenry, but you know we need that in henry, so there's going to be 10 to the minus 6th, okay? Now, let's calculate this, all right? So the C minimum here will be 1 divided by parenthesis again, 2 pi squared, then multiplied by 1650 times 10 to the third squared, times then 1 times 10 to the minus 6th, close those parentheses, and we get a value here of about 9.30 or so, times 10 to the minus 9th farads. You can call it microfarad, 9.3 microfarads, it doesn't matter. And now the other equation, okay, would be then this same thing, okay, this same exact thing. So let me just take this basically and copy it. It would be the same exact thing. The only difference now, my friends, is instead of it being a minimum, it's going to be a maximum, because I'm going to plug in now the smaller frequency. Now I'm assuming, if you go back to here, I'm assuming that this is 500 kilohertz as well. They don't really say definitively, but I think it would make the most sense to use that. So what I'm going to do is I'm basically going to plug everything back on into the calculator. I'm just going to go in and change the 1650 to now 500 and just let the calculator do its thing. So here now, the answer works out to be that the maximum here is going to be 1.01 times 10 to the minus 7th farad. Notice how this is larger than that. Okay, so that makes intuitive sense based on the math. So, I mean, this is kind of the range, I guess. Min and max. If they wanted you to find the difference between them, obviously you could just do a quick subtraction between those two numbers, and that works out to be about, the range. You might want it in terms of a difference. I don't know. Or they want the min and the max. Who knows? But 9.2 times 10 to the minus 8, that would be if you subtracted them. So anyway, one of them should suffice. Guys, thanks so much for tuning in. I appreciate it very much. Give us a hand. Hit the like button, subscribe, and maybe even tell some of your classmates, all right? Check out some of the other work we got. We're doing pre-calculus, chemistry, all right? And yeah, I will talk to you soon. Thank you.